In the question number 11, the axis pressure inside a soap bubble is equal to an oil column, height 3 millimeter. The total surface area of the soap bubble in contact with air will be given. Density of oil is 0.9 gram per centimeter cube. Surface tension of soap solution is given 0.03, and G you can take 10 meter per second square. Okay, so according to the problem, we can use the axis pressure, in the case of soap bubble 40 by R, where R is the radius, and that is equal to the column of height of 3 mm. So we'll write H rho G. So you know the value of surface tension from your question, 0.03, and radius R, that is equal 3 into 10 to the power minus 3, you know the value of H from the given data, into density 0.9 into 10 to the power 3, the value of G is 10. So by this expression you can easily calculate the value of R. So on solving you will get 4 upon 9 into 10 to the power minus 2 meter. But I need surface area. So surface area is given by 4 pi R square. But you know, because you are dealing the case of soap bubble, so multiplied by 2 surface area. So when you will put all values, you will get 496.2 10 to the power minus 6 meter square. So my option number 1 will be the right choice. So let's move on question number 12. In the question number 12, this is very good question. So you can use just like current electricity questions. In incompressible liquids flowing through horizontal pipe as shown in figure, the magnitude of velocity. So now I am going to use the principle of continuity, and you know AB is equal to constant. So if I use this, we'll write A1 B1, that is equal A2 B2 plus A3 B3, and I am going to take A1 B1 A2 B2. This one is 1, and I am going to take this one is 2, and this one is 3 point. So this is the principle of continuity, because you know AB is equal to constant, where A is the area of cross section and V is the speed. So now I am going to place the value. A1 is A according to the diagram, so A into 4, A2 1 into 2A plus V into 3A, because speeds are given, somewhere area is given. So when you will place the all values, so area will cancel out. So on solving you will get V is 2 by 3 meter per second, and this is a good question, so you can solve easily by taking this equation. So my option number 2 will be the right choice. So let's move on question number 13. In the question number 13, a container filled with a liquid of density 4 times of rho means density as shown in the figure. The velocity of efflux through orifice and density of water is rho, and value of G you can take 10. So in this question I am going to use the Bernoulli equation. You know the Bernoulli equation, P1 plus 1 by 2 rho 1 B1 square plus rho G H1, and P2 plus half rho 2 V2 square plus rho 2 GH2. So this is the Bernoulli equation, but 1 from inside of the container and 2 suffix for outside of the container. Then you can see this part will be 0. There is no kinetic energy in the case 1, or inside I am talking about inside liquid of the water, and outside there will be no potential energy. So finally I had P1 rho GH1 is equal to P2 and 1 by 2 rho V square. So P1 is atmospheric pressure P naught plus, because density is liquid density is 4 times of rho, 4 times of rho into GH. On the right hand side, P naught plus half rho square. Rho is 4 times and V square. So when I will solve P naught will cancel out. I have V is equal to 2GH once again. So when you will place the values, 2 in G is 10, height is 5, you will get 10 meter per second. So this is the velocity of efflux that I needed. So my option number 2 will be the right choice. So let's move on question number 14. In the question number 14, a boat floating in a lake is carrying a number of cork balls. If the cork are unloaded into water, then water level is. So this is a very good question. So I can solve just like that. Let's suppose mass of the cork ball, mass of cork wall, if I say capital M. So mg upthrust, mg will be upthrust, but when ball inside the boat, you have to be very careful, okay? And I can solve mg v, you know, by the principle, Archimedes principle, हमें कौन सा वॉल्यूम लेना है? Inside volume, dipped volume, and density of the liquid into G. Now, if I go liquid displaced, amount of liquid that displaced, liquid displaced, that is mass and density of the liquid. I can solve by this, and this is the N, liquid displaced. And if I say this is my observation number 1, and now I am going to take my observation number 2. When ball is dropped in water, अब अगर हम बॉल को वाटर में ड्रॉप करेंगे तो mg still as it is. So I can say when ball is dropped in the water, then still mg upthrust. There is no doubt about that. So now if I go V dash in the second case में, तो आप फिर से लिखोगे, you will write once again density. You will write m upon rho L means density, and this is my equation number 2. So we are seeing that displaced liquid m upon rho L, m upon rho L. So what is the meaning of that? So I would like to say, on the other hand, boat is floating in the both cases. Boat दोनों में flow कर रहा है. So total volume of water displaced in both cases are same, right? Hence, no change in level of liquid. So this is the reason. So by this discussion, I can say my option number 1 will be the right choice. So let's move on question number 15. In the question number 15, a human heart pump 50 cc of blood per heartbeat at a pressure of 1.5 meter of water. If the heartbeat are 75 per minute, then average pumping power of the heart is. So you can solve this question by using simple formula of power, but we'll see. This is a very interesting question. Power, you know, W upon T. In the case of thermodynamics or liquid, can I use work is equal to pressure into change in volume divided by T. So this is beautiful line for you. Now, I am looking to solve P because I need this pressure. So simply you can use H rho G because you have the value of height 1.5, density 10 to the power 3, and the value of G is 10. So when you will calculate, you will get the value of pressure. Second thing, I need delta V upon T. So 50 cc of blood. As I said, So I will write here 50 into 10 to the power minus 6 into 1.25 meter cube per second. 1.25 meter cube per second. So this is the value of dV over dt. Now I am going to use this P. So first I would like to place the value of P dV. So that is 15 into 10 to the power 3. 50 into 1.25 into 10 to the power minus 6. On solving, you will get 0.94 watt. So by this analysis, we can say my option number 3rd will be the right choice. So let's move on question number 16.